So what we're looking at today are characteristics of parabolas, kind of key features. And there's two kind of main key features that we have. One of them is the axis of symmetry. It is a line that divides the parabola into mirror images and passes through the vertex. Because the vertex of f of x equals a times x minus h plus k is h of x. The axis of symmetry is the vertical line x equals h. Yep. So our vertex is going to be the point h comma k. The axis of symmetry, which passes through the line, or through this vertex, will be x equals h. So really, if we know what the axis of symmetry is, we can really graph it because all the points to the right of the axis of symmetry will be the same as the points to the left. The y values will be the same, and it's a mirror image across this line. So if we look at the first example, the function is negative 2, parentheses x plus 3, close parentheses squares, plus 4. Our vertex is, for this here, is h comma k. So what would the h value for this be? Negative 3, and the k value would be 4. Because as we've been looking at these here with left and right, well, inside the parentheses is opposite of what we think, because really this is x minus negative 3, because the negative and negative would make a positive. And the reason we even talk about the negative is because in our general form, we have what? X minus h. The x minus h is causing us to get that different sign. So our vertex would be negative 3, 4. Now the axis of symmetry is x is equal to h. So here x is going to equal what? Negative 3. Here x is going to equal negative 3. And we have this here. And this here really is useful in graphing if we wanted to graph this. I'm going to erase this for now. But our vertex was at negative 3. 1, 2, 3, 4. Yep. This here would be the vertex. And our axis of symmetry is this line here. So that's the axis of symmetry, and everything is mirrored across it. Now, if I wanted to find other points of the parabola, I could just pick one. So let's just say negative 2. Well, to find the y value, I can plug it in. Well, negative 2 plus 3 is 1. 1 squared is 1. 1 times negative 2 is. And negative 2 plus 4 is 2. So we do have the point negative 2, 2. Now we said all the points on the right side will be mirrored across on the left. Well, how far is this point from the axis of symmetry? 1. So it's saying that the other point should be right here. Well, that is at what? Negative 4? Okay. Negative 2 times 4 plus 3 squared plus Well, negative 4 plus 3 squared. Well, it's negative 4 plus 3. Well, negative 1. Well, negative 1 squared is times negative 2 is. Will give us the value already because they're going to be 2. And I could do this for multiple points. So I could do this again with negative 1. So we can say negative 2 times negative 1 plus 3 squared plus 4. Well, negative 1 plus 3 is 2. Now 2 squared is 4. Negative 2 times 4 is, and negative 8 plus 4 is. So we have negative 1, negative 4. Now we got that a distance of 2 away from the axis of symmetry. So if I go 2 the other direction, 1, 2, I get the point negative 5, negative 4. Okay. And I can show that works by saying negative 2 times negative 5 plus 3 squared plus 4. That'd be negative 2. Negative 5 plus 3 is negative 2 squared plus 4. Well, negative 2 squared is 4. Negative 2 times 4 is negative 8. Plus 4 is negative 4. We get the exact same value. All of these points will mirror each other across that axis of symmetry. So really, to graph this here, if I know the vertex and the axis of symmetry, I get a starting point, and I can pick 3 points to either side, and it'll also give me the 3 points the other way. But we're not really focused on graphing. We're just focused on vertex and axis of symmetry. Questions on this here? Let's look at the next one. So the vertex is going to be our h comma k. So looking at this here, what would be the vertex? And since we have positive 4 inside the function for h, it would come out as negative 4. And the value of k would be negative 2. Axis of symmetry is our x is equal to h. So what would this equal? X is equal to negative 4. Questions on this here? All right, let's look at the next one. So we're looking at the graph of negative 3, parentheses, x plus 1, close parentheses, squared. What would the vertex be? Negative 1, 0. Because we don't have anything in the place of k, do we? So it has to be 0. Because whenever we're adding or subtracting something that's not there, it's always going to be 0. If we're multiplying or dividing a number that doesn't show up or isn't written, it's always 1. Now the axis of symmetry would be x is equal to what? Negative 1. And that's it. questions on this here? Let's go on and just look at this one here. Vertex, axis of symmetry. What would the vertex for this be? Since it's -2 inside the parentheses, it's going to come out as +2. And then we just take the 5. Our axis of symmetry would be x equals. That's it. That's all we have to do for this here. Any other questions on this here? Now, what we were just looking at is the equation in what we will call vertex form. Now, what we're going to look at next is the equation in what we'll call standard form. And the standard form is going to be y equals ax squared plus bx plus c, and it'll be on the next slide. Now what this is, so actually it's right up there, ax squared plus bx plus c. That is it in standard form. Now this slide, what it's telling us is kind of showing us how a, h, and k all relate to a, b, and c. And there is some more information here about, so a is the same meaning in vertex and standard form. B is the same as -2ah, and we can solve for h. And C is the y-intercept. But really, if we look at this here, and I did provide this on the next page of your note sheet, whenever a is greater than 0, it opens up. When a is less than 0, it opens down. So it's either going to open up or open down. The graph narrows when the absolute value of a is greater than 1 and widens when a is less than 1. Now the axis of symmetry for this here is still going to be x is equal to, but now it's going to be -b over 2a. Our vertex is going to be the point -b over 2a, comma, f of -b over 2a. And they'll also include this here, but the y-intercept well, the y-intercept is wherever it crosses the y-axis, yes? And the x value of the y-axis is always 0. We haven't gone anywhere left or right. Now it says already that the y-intercept is going to be 0, comma, c, because we know that at the y-axis the x value is 0, yes? Well, here I'm going to use a, b, and c for any values of a, b, and c when x is 0. Well, what is a times 0 squared? What is a times 0 squared? 0. That's just 0. What's b times 0? So what's left over? So if it crosses the y-axis, when it does cross the y-axis, it's going to be at c, because ax squared plus bx, all of that's going to become 0. We're just left with c. Okay. Any questions on this here before we look at our first example problem? Let's go on and look at an example of this. Okay. I'm going to give my space a little bit, I'm going to leave a little bit of space to work. Well, actually, no, let's just put this up at the top. So the two things we're going to look at for is the vertex. Now, because it is in standard form, we're going to have -b over 2a, comma, f of -b over 2a. And the axis of symmetry is x is equal to negative b over 2a. And we'll have x is equal to here. So let's start off with writing this here because we're going to fill those in. And we know A of S is really just the axis of symmetry. Now I'm going to write this here because again, I'm not focused on the actual graph. You have a little bit more space to write because you guys can write it underneath. I'm just going to write it out to the side. Now looking at this here, what's the value of A, B, and C? Because the general form is ax squared plus bx plus c. Does the a value, will the a value ever contain x squared? Will the value of a ever contain the x squared? Well, no, it's ax squared. Yes, those are two separate units. Bx is b times x, the value of b times x. So when I look at this here, 3x squared minus 6x plus 1, well, a is the 3, b is the negative 6, and c is the 1. Those are the values for here. So if I want to find the vertex, it's negative b over 2a. Well, negative, what is b? Over 2 times, simplify, and we have the x value of the vertex. Because all I've done is plug in for a, b, a and b, negative b over 2a. Well, if we simplify this, well, negative 6 is 2 times 3 is 6 divided by 6 is. So the x value of the vertex is 1. Well, heck, we also have the axis of symmetry, don't we? Because the axis of symmetry is x is equal to negative b over 2a. X is equal to 1. So we not only have the x value of the vertex, we also have the x value of the axis of symmetry. Well, the only thing we're missing is the y value of the vertex, yes? Well, they told us it is what? F of negative b over 2a. Well, f of, well, we know what negative b over 2a it is what? So I'm taking f of 1. What does that mean, really, what we're doing? We're taking 1 and doing what? Back into the function. Because f of x is our function, yes? That's all we're saying is I find the x value and plug it back in. So we're taking 3 times 1 squared minus 6 times 1 plus 1. Because this will give me the y value. F of x is y. So we really want to know what is the y value when x is 1. Okay. Let's look at this here. So we just need to simplify this for 1. Well, are there any variables in that part of the equation? Well, no. It's just 3 times 1 squared minus 6 times 1 plus 1, yes? We can type this into the calculator. Or I can do it by hand. 1 squared is 1. 6 times 1 is 6 plus 1. 3 times 1 is 3. Negative 6 plus 1 is negative 5. 3 minus 5 is? So the vertex is going to be the point 1 comma negative 2. And the axis of symmetry is x is equal to 1. Any questions on this here? Okay. No questions on this here. Let's go on and look at the next one. vertex is our negative b over 2a, comma, f of negative b over 2a. Our axis of symmetry is going to be x is equal to negative b over 2a. Okay. You need to go away. This one here will be the next problem. So, what do we need to find first to find the vertex or the axis of symmetry? The value of x, the negative b over 2a. So we have negative. What is our b value? Over 2 times a, and a is what? 1. Well, on top we would have negative 2. 2 times 1 is 2. And negative 2 divided by 2 is? So the x value of the vertex is? Negative 1. What's the axis of symmetry? X equals negative 1. Any questions on this here? So what's the only thing we're missing? The y value of the vertex, yes? And to get the y value of the vertex, what are we going to do? F of negative 1, or here it would be considered h of negative 1, but really we're just plugging it back into the function. We're plugging it back in. So we'll plug it back in, so x squared, negative 1 squared, plus 2 times negative 1 minus 1. So we'll go on and solve this. Negative 1 squared is 1. 2 times negative 1 would be negative 2 minus 1. Now what is 1 minus 2 minus 1? What is 1 minus 2 minus 1? So 1 minus 2 is negative 1, minus 1 is? What is 1 minus 1? So I'm just left with negative 2. So the y value of the vertex is negative 2. So we have the point negative 1, comma, negative 2. Any questions on this here? We're ready to look at the next one. Yes? Let's look at this one here. Well, our vertex is what? Our negative b over 2a, comma, f of negative b over 2a. Or really, we find out what the x value of the vertex is and plug it in to find the y. So here we'll have negative what? Negative 8 over 2 times what? Well, negative 8 is just 8. The negative and negative make a positive. 2 times negative 2 would be negative 4. 8 divided by negative 4 is negative 2. So the x value of the vertex is negative 2. The axis of symmetry is x is equal to Now to find the y value, we just need to plug that x value back in, yes? So if we plug it back in, we'll have negative 2 parentheses, negative 2 parentheses squared minus 8 times negative 2 plus 1. And again, we could have typed this all into the calculator and gotten our answer. Or if we simplify this by hand, well, negative 2 squared is 4. Negative 8 times negative 2 is going to be plus 16 plus 1. Negative 2 times 4 is going to be negative 8. 16 plus 1 is, and negative 8 plus 17 is, so the vertex is, I'm going to scroll up, negative 2 comma 9. And the axis of symmetry is x equals negative 2, yes? Okay. Now, this is the last type of problem like this. Are there any questions on this before we talk about the next piece? Okay. Let's look at the graphing calculator. Hit y equals and type that last one in. Our negative 2x squared minus 8x plus 2. So we can say negative 2x squared minus 8x plus 1. And once you get that typed in, go on and hit graph. Yeah. Also, if you all haven't noticed, it does give you the key press history right there. So this right here is all the buttons I hit to get there. So once you get that all typed in, hit graph. We got that typed in. So if we hit graph, we all get something that looks like this here, yes? Well, there's our vertex, the highest point for this graph. And it looks like, so we said negative 2. It does look like it lines up at negative 2, yes? Questions? Well, what we can do also is if we hit second graph, it will pull up a table. So it'll tell us if we go to negative 2, the y value at when x is negative 2 is what? What does it tell us? 9. What's the value of y when x is negative 1? 7. Well, hey, look, when x is negative 3, the y value is also 7. Because we know also that x equals negative 2 is the axis of symmetry, and all the points to either side should mirror it. So we have 9, 7, 1, 9, negative 9, 23 going up. Going down, we have 7, 1, negative 9, negative 23, negative 41, and negative 63. So if we looked when x was negative 7, what do we expect the y value to be? Negative 41, because right after negative 23, going down was negative 41. So we expect going the other direction, it should be negative 41, because these points will always mirror each other to either side. Because we do get this parabola here where the points to either side of it do mirror each other. Any questions on this here? Okay. So we're going to go back to the note sheet. Now we do have some different features here that aren't written down, but they are listed up here. We have the maximum and minimum value, the domain range, increasing and decreasing. One of the main things I would point out is that the domain for both of these is all real numbers, because this will stay pretty much true until we start talking about rational functions, rational ratio, fractional functions where the variable is in the denominator, or radical functions where we have square roots, cubed roots, fourth roots. Those, the domain will not be all real numbers. But for these here, for these quadratics, the domain is going to be all real numbers. Now we look at this one here, when it's opening up, it says that it has a minimum value. And the reason for this is because if I pick any point on either the right side of the parabola or the left, no matter what point I pick going in either direction, there's going to be a point bigger than it. Because it's opening up, those two sides of the parabola will continue to increase forever and ever. So no matter what point I pick going this direction, there's always going to be a point greater than it after it. But the vertex here, is there any point that is lower than this point? No, because if I go to the left of it or to the right of it, it starts going back up. So if the parabola opens up, the vertex is going to be at the minimum value, and we're mainly focused on the y value of the vertex. Because the y value of the vertex would be the minimum value, the smallest value for this here. Well, as we just said, this is the smallest value. That means its range is going to be all the values of y greater than it. Because if that is the smallest value, the y values of the function have to be bigger than it. Because all the points on the function on the graph are going to be above it. And then we'll look at decreasing and increasing here in a minute. Now, if we look at this one here, it is opening down. So if I went to the left or right, no matter what point I picked on this, there's always going to be one that is smaller because it's going down, which means our vertex is not going to be the minimum value, it's going to be the maximum, because I can't find another point on the graph that's bigger than that point. So its y value will be the maximum value. And again, we said it's going down, so the range is going to be all the y values that are less than or equal to that point. So it's kind of handy to know what it is. And we'll look at increasing and decreasing when we look at the functions. So let's look at this first problem here. Finding the maximum or minimum value of this function. Describe the domain and range of the function and whether the function is increasing, where the function is increasing and decreasing. So what do we think? Would this have a maximum or minimum value? Which way would it be opening? Well, if it's hard to say, why don't we go look at the graph of it? So let's graph it. Let's hit y equals, and let's plug it in. So if I want a fraction, we're going to go alpha y equals, enter. Well, I'm going to clear that out first. Alpha y equals, enter. So I cleared it, and then when alpha y equals enter, so the function's gone. Now our first value is 1/2 x squared minus 2x minus 1. Any questions on how we type this in? Any other questions? alpha y equals enter. Alpha y equals enter will give us the fraction. Once you get that typed in, go on and hit graph. Once you get the whole thing typed in, go on and hit graph. Yep. Let's see here. Okay, so it's not wanting to do fractions. I'll have to memory about. Okay. 7, 1, 2. Alpha y equals. Yeah, there was some preset that was messing it up. Alpha y equals. Okay. Once we get it typed in and you hit graph, the function's also on your sheet. Which direction does this open? Up, yes? So would we have a maximum or minimum value? Minimum, yes? It's the lowest point. Now, hit second trace, second calculate. Well, look at this here. So number 3 is minimum, isn't it? So I can go down and select minimum. So go down to 3 and hit enter. So once you go down to 3 and hit enter, I think you should have a screen like this here at the bottom. It says left bound. What this is asking is to pick a point to the left of the minimum value. Well, is that blinking X already to the left of it? Well, where's the minimum value? At the bottom of that view. So it's already to the left. So we can go on and hit enter. The next thing it asks is right bound, yes? Well, now we need this to the right. So we'll hit the right arrow to move it over. It doesn't matter how far to the right it is, but we just need it to the right of wherever that lowest point is. And once we get it to the right of that lowest point, we can go on and hit enter. So you have those 2 lines or at least 2 arrows. What that's saying is that the minimum is going to be between those 2 values. And we want to hit enter one more time. And it tells us that the minimum is -2, 3. Negative, or 2, -3. And we will pick this up tomorrow.